This is Pre-Calc section 10.2, part 2 on parabolas. In part 1, we looked at parabolas that were already in standard form, one of these two forms, whether it's a horizontal parabola or a vertical parabola. Now we're going to look at a couple that are not in standard form. So we're going to have to take this equation and get it into one of these two forms. Now, you need to look over here and see that this is y squared, and because it is y squared, this is the form we're trying to get to. And the only way we're going to get this into this form is to complete the square. Now, because it's y squared, we are completing the square on the y terms. And ordinarily, I would say, move the 8x over, also move the 4 over. But it just so happens that the 4 does make this a perfect square trinomial, in which case I don't have to complete the square. It is already a perfect square trinomial. You'll see on the next one where we actually do have to complete the square. So that just saves us a step or two. So what we want to do with this is factor this into parentheses, and how that factors is y minus 2. So what we have here is the standard form. And then we should be able to name the vertex, the focus, and the directrix from there. Now, when we look at this, when you see that it's y squared, when it's y squared, that tells you that this is a horizontal parabola. Y squared is a horizontal parabola. Also, because that coefficient is negative, this is going to open to the left. So once I name my vertex, I can get a so-so graph over here, and that will help us name the focus and directrix. So the vertex will be 0, because there's no parentheses here with the x, comma 2. My vertex is 0, comma 2. It's not listed here as one of the things we have to name. It says name the vertex, focus, and directrix, but I do need to find out what A is. That's the only way I'll be able to find the focus and directrix. So to find out what A is, this, remember, this coefficient corresponds to the 4A that is in the standard form. So if you solve that, you will get A equals negative 2. So let's go to the graph. We're going to graph the vertex of 0, 2. And I know that this opens left, so I'm just going to do a sloppy little graph over here. Didn't quite hit that dot there. So that's what my parabola looks like somewhat. Since A is negative 2, the focus for a horizontal parabola, remember if it's a horizontal parabola, you are going to be making changes onto the horizontal part of the vertex. So this is 0 plus negative 2, comma 2. And of course, 0 plus negative 2 is negative 2, comma 2. So my focus is over 2 and up 2, which puts the focus right there inside the parabola where it belongs. The directrix is a horizontal, so the directrix is a vertical line because this is a horizontal parabola. Therefore, this is x equals 0 minus negative 2, which gives me x equals 2. And that's all we had to name. This next one is very similar to name the same things, but this one I am going to have to complete the square. This one's a teeny bit different from the last one because the only thing that is on this left side are the x terms. So I didn't have to move anything to the right side, but I do need to put my blank for the completing of the square. And we know how to complete the square. Take half of the middle, half of 6 is 3, 3 squared is 9. That's what gets added to both sides. The reason to put that 9 there is to make this into a perfect square trinomial, which will now factor into x plus 3 squared. A little bit of arithmetic over here is 4y plus 4. Now we've got to do one more thing. What we're looking at is this form right here. And notice I can't leave this as 4y plus 4. I've got to have something in front of the parentheses. So I need to factor out the 4. And now it is in standard form. And before we start naming these things, let's talk about what kind of parabola this is. This is x squared, and if it is x squared, then we know it is a vertical parabola. Also, because this coefficient is positive, it opens up. So take a look at the form. Your vertex is negative 3, comma negative 1. So I can go over here to the graph, negative 3, negative 1, and I know my parabola looks something like this. Of course, I don't know how fat or skinny it is. I'm just giving this a visual here to help us with the focus and the directrix. So at this point, I need to get A, so that will help me get the focus and directrix. So I set 4 equal to 4A, solve that, and I get A equals 1. So this is a vertical parabola. Because it is a vertical parabola, the A has to be added onto the vertical part of my vertex. So the focus will be -3, comma, -1 plus 1, which is -3, 0. Which picture-wise, over 3, and up 0 is right there. There's my focus inside the parabola where it belongs. The directrix is down here, and it is a horizontal line, so it's y equals -1 minus 1, which is -2. So that's all the information we needed, and there is our little sloppy graph. All right, we have a new term to look at here. The latus rectum is the line segment that is perpendicular to the axis of the parabola, the axis of symmetry, through the focus and whose endpoints lie on the parabola. So this is already drawn out for us. Let me show you exactly what I'm talking about here. It is a line segment that is perpendicular to the axis of symmetry. The axis of symmetry for this parabola right here is the y-axis. If I have this segment here, it is perpendicular. See, that's perpendicular to the axis. But not only perpendicular to the axis, it has to go through the focus. So that black line I just put right in there is the latus rectum. And the endpoints of that have to lie on the parabola. Now let's go back up here and look at these numbers because these numbers are important to us. Now I'm assuming that this vertex here is the origin. This vertex is the origin, and this is the focus. And we know the focus is a distance of a units away from the vertex. This latus rectum total width from here to here is defined to be 4a, which means from the focus over to the endpoint is 2a, and from the focus over to that side is 2a. So let's just take a look at some numbers. Let's just pretend our vertex is right here at the origin, and let's say the focus is right here, and that a is a distance of 3. I'm just making that up. It has nothing to do with that picture right there. So if a is 3, then I know that this distance across here is twice that. So this is the ordered pair 6, 3. Now where does the 3 come from? This is a height of 3 right here, which means this is a height of 3 right here. Over here, it's just going in the other direction. This is -6, 3. So you're going to be asked on the next several problems to find the endpoints of the latus rectum, and it's very easy to find. You can follow the fact that from the focus out to the endpoint is a distance of 2 times the a value. And the a value will either be given to you or you'll be able to figure it out from other information. Now, if you have a sideways parabola, then here's the sideways parabola. There's my vertex, there's my focus, and let's slide this in. That black line right there is my latus rectum because it is perpendicular to the axis of symmetry, and it's got endpoints that are on the parabola, there and there. And we still have the same information. From the vertex to the focus is a distance of a. And from here out to the endpoint is a distance of 2a. So let's put some arithmetic on here. Let's just say that, let's say this is 5. Then that means this distance is 10, and this distance is also 10. And to name this ordered pair, this is over 5, up 10. And remember, I'm just making up these numbers of 5. It has nothing to do with that picture right there. This is over 5 and down 10. So that's what we're going to use to get the latus rectum. So this is a problem that's asking us to work our way backwards. It says find the equation of the parabola with focus -7, 0 and vertex 0, 0, and then find the 2 points that define the latus rectum and sketch a graph. Now, it makes it sound like sketch the graph should happen at the end. I like to go directly to the graph to have an idea of what kind of parabola I'm dealing with because that helps me get the right formula. So it's got a focus at -7, 0. So there's my focus. And if my focus is on this axis and my vertex is 0, 0, that tells me that I have a sideways parabola. It has to. Also, it is facing to the left. Now, instead of memorizing, we know we have these standard forms back here. There's two standard forms. You could memorize those, but I kind of like to build them and not have to do the memorizing. And this is what I do. I do x minus h, put it in parentheses, and I got an equal sign in here, and I go over here and I do y minus k, because I know that's going to be involved. Now I know sometimes h and k are 0, 0, and I'll fix that in a second. But because this is a sideways parabola, I know that the squared goes on the y. The other thing I know is that your 4a coefficient goes on the non-squared term. So that's the way I build this, so I don't have to do the whole memorizing of where things are. I have the x minus h, the y minus k. I know since it's sideways, it's squared. Also, this was facing to the left, so I should have had a negative over here. Let's plug in a couple things that we know. We know that the vertex is 0, 0, so I don't need the x minus h. So what I have is negative 4ax, because h is 0, just get x. Same thing on the other side, because k is 0 equals y squared. So I'm dealing with that standard form because the vertex is the origin. The other thing I know is that this is the vertex and this is the focus, which means this is 7 units. From 0 to the focus is going to be 7. So if I put in 7 for A, I have a formula of negative 28x equals y squared. So that's the first thing it asked me. What is the equation of the parabola with that focus and that vertex? So that's what I have. The next thing is to come up with the latus rectum. Now the latus rectum goes through the focus. I should have continued this a little bit more. Goes through the focus. And I'm looking for those ordered pairs. Well, if this is a distance of 7, now notice which way it is. We're facing to the left, so this is negative 7, because we're going to the left side, and so is this one. All I have to figure out is the y values, and we know from the previous that this is 2 times a, which is 2 times 7, which is 14. So this is up 14, this is down 14. So those are the points that define the latus rectum. New problem, new information. We have a vertex of 0, 0. We have a directrix of y equals 1/8. So it's hard for me to get it exactly in the right place, but I do know it is up here just barely above the x-axis. And what that tells me, because my directrix is a horizontal line, that tells me that my parabola is an upside down vertical parabola, something like this. So this is a vertical parabola and it is facing down. Now, same thing I did on the last problem. I'm going to build this standard form. Here's my x minus h. Here's my y minus k. And I know, because it is a vertical parabola, that it's the x that's squared. I also know that it is facing down, and the coefficient goes with the non-squared term, so this is negative 4a right there. I also know that the vertex is 0, 0, so really I can just go with x squared equals negative 4ay. So that's my standard form for the vertical parabola that is at the origin. So I can plug in the fact that if this is y equals 1/8, that means that a is 1/8, because a is the distance from the vertex to the directrix. So plugging that in, I have x squared equals negative 4 times 1/8 times y, and reduce that. Negative 4 times 1/8 is negative 1/2 y. So there is my equation of the parabola with this information. Then it wants me to define the latus rectum. So the latus rectum, remember, goes through the focus. Now the focus would be just barely below here, because if a is 1/8, the focus is 1/8 down. So my latus rectum is going to go about right here, and I need to come up with those endpoints. Well, the thing I know for sure is that this distance from the vertex down to the focus is 1/8. So I know the y values for each of these will be negative 1/8, negative because we've gone down. And my x values will be this distance, which is twice that. So 2 times negative 1/8 will be negative 1/4. And on this side would be positive 1/4.